Types of functions. We are studying the first chapter, relations and functions. Today's topic is types of functions. Number one, one-to-one function. A function f from a to b is called a one-to-one function if distinct elements of a has distinct images in b. It is also called an injection. So here, example, a is set 1, 2, 3, b is abc. So here is the function. These are the ordered pairs. The image of 1 is A, image of 2 is B, image of 3 is C. Here you can see distinct elements of A has got distinct images in B. So this is a one-to-one function. Many-one function. A function is called many-one function if two or more elements of A has the same image in B. So here the set A, B and G is the function. The ordered pairs are the image of 1 is A, the image of 2 also is A, image of 3 is C. So here you can see two elements of A has the same image in B, that is A. Therefore, this is a many-one function. Third one, onto function. A function f from A to B is called an onto function if the range of f is equal to the codomain B of f. It is also called an surjection. If a function is 1, 1 and onto, then it is called bijection. So here, onto function means that the range should be equal to the codomain. Onto is also called a surjection. And if a function is 1 to 1 and onto, then it is called a bijection. So here is an example. This is set A, this is B. Function here. Here you can see the range of this function is A, B, C, which is the same as the codomain. See, range is equal to codomain B. So this is an onto function. Into function. A function is called an into function if there exists at least one element in B which is not in the image of any element of A. That means the range will not be equal to the codomain. So here is the example. Here you can see that ABC is the range and it is not equal to the codomain B. Is it not? So this is an into function. All this will become very clear when we do sums in the exercise. Exercise 1.4. I've already solved questions 1 to 3 in the previous video. Please go through that. Here we are going to do from question 4. Show that the function f from n to n defined by fx is equal to 2x minus 1 is 1 to 1 but not onto. So let us write down the functions. F is from n to n. N you know is the set of natural numbers. Here it is. The function is fx is equal to 2x minus 1. So here let us take different elements of n as x. Okay. Let us start with 1. Put x is equal to 1 here. Substitute here also x is equal to 1 and solve. You get f at 1 is 1. So here we say that image of 1 is 1. Okay. F at 2. Okay. Well, let's find the image of 2. Okay. So here put it here. X is equal to 2. Solve it. You get 3. So image of 2 is 3 under the function f. Image of 3 under f is 5. Image of 4 under f is 7. So here you can see that distinct elements of this set A, that is the domain. Here in this case it's a set of natural numbers. Okay, will have distinct images in the codomain. So here let's write down. Domain is the set of natural numbers. Codomain is also the set of natural numbers. The range is 1, 3, 5, 7 ... So distinct elements has distinct images. Hence it is 1 to 1 and codomain is not equal to range. You can see they are completely different. Hence it is not onto function. Question 5. Show that the function f from n to n defined by fm is equal to m square plus m plus 3 is a one-to-one function. Similarly, you have to write down the function. F is from n to n. N is the set of natural numbers. Write down the function fm is equal to m square plus m plus 3. Here we are going to substitute the values of m, okay, from here, the domain, which is a set of natural numbers. Let's start with 1. F at 1 is 5. Substitute here and solve it. You will get 5. F at 2, put m is equal to 2. So 2 square plus 2 plus 3, that is equal to 9. F at 3 is 15. F at 4 is 23. So let's write down. The domain is n, the set of natural numbers. Codomain is the set of natural numbers. Range is these values which you found, 5, 9, 15, 23, and many more you will get for different values. Okay, so here distinct elements of domain has distinct images under F, hence it is one-to-one function. Let A is equal to 1, 2, 3, 4, B is equal to n. Let F from A to B be defined by fx is equal to x cube. Then find the range of f, identify the type of function. So let's write down A is equal to 1, 2, 3, 4, B is equal to set n, which is set of natural numbers. The function is x cube, fx is equal to x cube. Now substitute these values of x is equal to 1. You get f at 1 is 1. F at 2 is 2 cube, which is 8. F at 3 is 3 cube, 27. F at 4 is 4 cube, 64. So the domain is 1, 2, 3, 4. Codomain is natural number set. Range is 1, 8, 27, 64. So range is not equal to the codomain. Okay, this B is the codomain. So this function, different elements of A has different images, hence it is one-to-one, and into function because range is not equal to codomain. Okay, it is not an onto function. Okay. Question 7. In each of the following cases, state whether the function is bijective or not. Justify your answer. Sum 1. F is from R to R defined by fx is equal to 2x plus 1. So let's do this first. Here, write down the function. Fx is equal to 2x plus 1. And the domain is R. R is the set of real numbers. You studied about real numbers in 9th standard. And even the codomain is real numbers. Okay, so it can take any value, any real number value. Here I have just taken some integers only, but you can take negative numbers, fractions, anything. Okay, they are all real numbers. Anyway, distinct elements of this domain R I have taken, found out that all the images are distinct. Hence, this function is a one-to-one function. Okay, now we have to find out if this range of this function is equal to the codomain. Again, the codomain is R. All the elements of codomain have pre-images in domain. That means take any element of codomain, it will have a pre-image in domain because domain itself is a real number set. Okay, hence the range is equal to codomain and it is an onto function. Hence, it is bijective. Sum number 2, function R to R defined by fx is equal to 3 minus 4 x square. Okay, so here we have to find out what kind of function is this. Okay. So here I am going to specifically take two values of x which belongs to R, real number set, that is minus 1 and 1. So here f at minus 1, substitute minus 1 here. Simplify, you get minus 1. And f at 1, substitute x as 1, you get minus 1. So there are two elements in the domain R which has got the same image in the codomain, again which is R, this same image. Hence, this is not a one-to-one function, hence not bijective. For a function to be bijective, it should be one-to-one and onto. Question 8. Let A is equal to minus 1, 1 and B is equal to 0, 2. If the function f from A to B defined by fx is equal to ax plus b is an onto function, find A and B. So first let us write down what all is given. Set A is given, minus 1, 1, B is 0, 2 and the function is given as ax plus b. Okay. So here what we understand is that it is an onto function. Okay. Onto function means this is the image of this element of A. So let's write it down. So f at minus 1 is equal to, substitute x is equal to minus 1 plus b is equal to 0 I am writing because it is an onto function and this is the image of minus 1. Okay, so write it 0 and then simplify, you get a is equal to b. Now for the second, again write down x is equal to 1, substitute here, and the image of this 1 is what? 2. So this is equal to 2. F of 1 is equal to 2. So write down. So a plus b is equal to 2. A is equal to b. Substitute here. In place of b, write down a. So 2a is equal to 2. A is equal to 1. And a is equal to b. So this is equal to b also. So a is equal to 1. B is equal to 1 is the answer. So here we come to the end of this video.